Okay, we're on the notes for 4.4, trig functions of any angle, regardless of unit circle or not. And for number 3 here, it says let negative 3, 4 be a point on the terminal side of the angle. So we have the angle in red here. The terminal side is the side that it ends, and at that point we have, or on that terminal side, we have this point, negative 3, 3, 4. First thing we need to do is identify, again, we're building the triangle that we're going to work with to build our trig functions is basically based off of the reference angle. So we drop a line down to the x-axis from our terminal side. Here's our triangle. This is negative 3. This is 4. We need our radius. Well, again, right triangle, legs of 3 and 4, then the hypotenuse or the radius has to be 5. Now we have our x, y, and our radius and our r. So we can do our cosine theta is adjacent negative 3 over hypotenuse, which is 5. Sine theta is opposite side 4 over our hypotenuse 5. Tangent theta is opposite 4 over our adjacent negative 3. Yes, I put the negative 3 down there, but that's the same as negative 4/3. Don't get caught up on where the negative is, except for when we look at some problems here in a bit. Cotangent theta is going to be negative 3/4. Secant theta is the reciprocal, so that'd be negative 5/3. And cosecant theta is the reciprocal of sine, so that's going to be 5/4. All right, slide over here, number 4, same concept. We have an angle in red. The terminal side of our angle has the point 2, negative 3. Again, we're not concerned about this angle here that we've drawn, right? We're concerned about the reference angle, because that's basically this angle is what we're going to use to get our different trig functions. So the x value is 2, the y value is negative 3. We have to do our Pythagorean. So 2 squared plus negative 3 squared equals r squared. 4 plus 9 equals r squared. And so we have r equals the square root of 13, which is right here, square root of 13. And now we can do all of our sine theta equals, oh shoot, get that back in here, get this point back here, and what I was trying to do is I was trying to rewrite this as the square root of 13, and I can put this back in, oops. All right, so tangent is opposite negative 3 over square root of 13, which is negative 3 root 13 over 13. Cosine theta, adjacent 2 over root 13, which is 2 root 13 over 13. Tangent theta, opposite negative 3 over adjacent 2. Cotangent theta, the reciprocal, negative 2/3. Secant theta is the reciprocal of our sine, so it's going to be negative root 13 over 3. And lastly, cosecant theta, reciprocal of cosine, so that's going to be root 13 over 2. Moving along here, number 5. Sort of the same idea, but we have the sine of the angle is negative 2/3, and then it gives us this little clue here. Tangent of the angle is greater than 0. In other words, it is positive. And if we, and it was like, why? Well, we know that our y value is negative 2, and our hypotenuse, our radius is 3, and the radius can never be negative. It has to be positive. So when we see negative 2/3, the negative carries over to the 2. We can use our Pythagorean theorem to find our x value, which would be square root of 5. But the question is it positive or negative? In other words, is this triangle that we're going to be drawing, is it going to be at a negative root 5, negative 2? Oops. Is it going to be here, or is it going to be over here? Since tangent is positive and tangent, since tangent is y over x, excuse me, if the y value is negative, the x value has to be positive in order for tangent to be negative. Oh, I'm sorry, tangent is positive. So if the y value is negative, if this is negative, then the x value needs to be negative because the two negatives equal positive. All right, so with that information, we know that x has to be negative. Therefore, we're looking at a point down here of negative square root of 5 and negative 2. Something like that. Our reference comes down here. So there's our triangle. This is going to be negative root 5. This is going to be negative 2. And we know that our radius is 3. So we use that to build all of our ratio. Oh, nope, all one was cosine theta. Cosine theta equals adjacent, negative root 5 over the hypotenuse of 3. And then cotangent theta is going to be the adjacent, negative root 5, over the opposite, negative 2. So this is root 5 over 2, positive. Number 6, lastly, same idea, but this time tangent is negative. But we see that our y is positive. Therefore, we know that our x has to be negative. One leg is 4. The hypotenuse is 5. Therefore, by rule, on a right triangle, x has to be 3. If you don't believe me or aren't sure, go ahead and do the Pythagorean theorem. You'll find that x equals 3. And since tangent is negative, then x has to be negative 3. So we go negative 3 and 4 is somewhere like right here. So again, here's our angle. That's the initial side. Here's our terminal side. From the point on our terminal side, we drop down and we create our triangle. Sine, this is our y value, 4. Our x value is negative 3. And our hypotenuse is a radius 5. And we want to find the cosine. Cosine of theta is adjacent, negative 3 over hypotenuse 5. And cosecant theta is basically 1. Remember, cosecant is 1 over sine theta. It's the reciprocal of sine theta. So cosecant, since sine theta is 4/5, this is like 1 over 4/5 equals 5/4. If you want the math part of it. All right, that's it. We'll do probably 2